Today we're going to go over Leetcode question number 11, container with most water. Given n non-negative integers, where each represent a point at a coordinate and a vertical line drawn between the two endpoints, find two lines which together with x-axis forms a container such that that container contains the most water. So this is a diagram here. So what we have here is 9 lines, and we want to find the 2 lines which make up the container which has the maximum area between them. We can ignore the lines in between these 2 lines and consider the width negligible. So let's look at how we can implement this algorithm. So starting off, we can assume that the difference between each of these lines is 1. That makes calculating the area a lot easier. The area would then just be the height of the shorter line and the difference. So for example, if this is equal to the width, we will take the shorter height, which here would be the minimum between height 1 and height 2. And then our area would just be the width times the minimum between height 1 and height 2. So if we were to brute force this question, one thing that we can do is compare the area between all the different combinations of the lines. So how will we optimize this so we wouldn't be operating in O(n) squared time? Well, one possible way is thinking about what makes the height increase or decrease. We know from the question that the distance between each of these lines is 1. We would know that the area would decrease if we move towards a line which is shorter. And we would know that the area may potentially increase if we move towards a line which is taller. More specifically, say if we have 2 lines and we want to increase its area, we should take the shorter line and check if the line beside it is actually taller. If the line is taller, then there is the potential of increasing this area. So how we can do this is we can start off at the 2 ends of this list of lines, and we can slowly move the 2 lines closer to each other and check every time to see what's the maximum area. So we will be moving in this direction and in this direction as well until the 2 lines meet. And how we pick which line to move is based off of which line is shorter. Remember that the line that is shorter is limiting the area. So we want to move the line that is shorter in order to check if the following line is taller so that it may potentially increase the area that we have. So let's write this out in Python. First off, we set the max area to 0, and then we set 2 points at the beginning and the end of the list, which I'll call left index and right index. Now all we have to do is continue looping until the left index reaches the right index. And what we do for every iteration is based off of which line is shorter. So if the line on the left is shorter, what we do is first of all we calculate the area, which would be the shorter line, times the difference between the right index and the left index. And then we move the shorter line, which is on the left, forward 1 spot closer to the right index. Likewise, if the line on the right is shorter, again we calculate the area and then we move the right line closer to the left line by 1 index again. So that is a subtraction. Then all we have to do is update the maximum area. If we want, we can also keep a record of what the indexes of these 2 lines are. And that is all we need to do. Then we can just return the max area. So let's run this. Here, what we actually see is that it's printing out the indexes of the next iteration. So we updated the indexes before we printed them out. So what we actually want to do is print out the indexes before it was updated. So we can change our code simply by doing this. We can move this if statement inside each of these loops before the indexes are updated. Let's run our code again. So what we see here is the first output is when the two indexes are at their starting position. That would always give us an area greater than 0. Then what we see is the next max area, which is when we move left forward 1 position. We can also print out the area. Now let's try out some other cases. If there's only 2 lines, we do get the area for only those 2 lines. So that's good. And we can increase it to 3 lines, where the lines corresponding to the maximum area are inside. Interestingly, what we do see is that when we are at position 1 and 3, so that is 6 and 3, our area is 6. But if we also move right forward 1, our area will also still be 6. That will be between 6 and 7. Now let's put something in between here, increase the difference between the 2 maximum lengths. So what we see here is that the maximum is now between 6 and 4. And here, now the maximum is between these 2 lines, 34 and 12. Mainly because they are so much taller than the other lines that the distance along the x-axis is compensated for. Let's submit our code and see what we get. So it does pass all of our tests. Now let's look at the ON time. In terms of speed, what we are doing in this algorithm is we are moving from the ends of the list towards each other. And each time we are just storing a variable called area and a variable called maximum area. So in terms of computational speed, we are actually operating at ON time, where n is the length of the list. We only go through each of the elements of the list once. In terms of memory, what we do keep track of for every iteration is just the area for that iteration, as well as the maximum area that we have so far. So we have a constant number of variables that we do keep track of, and that will give us a memory efficiency of 0.1.